Hello, welcome to Flipped. So today we are on kinetic particle theory, focusing on the changes in states, also known as the interconversion between states. And how can we change state? It's really just to change the temperature. For example, solid to liquid is melting, liquid to gas is boiling, gas back to liquid is condensation, liquid back to solid is called freezing, and solid to gas directly, skipping the liquid phase, is called sublimation, and gas to solid, skipping the liquid phase, is deposition. We won't really be talking about deposition much because it's not really in syllabus, but we will focus on sublimation. Okay, let's move on. Start with melting. So melting is really just from solid to liquid, and this is as such is when we heat solid to a certain temperature called a melting point, it changes to a liquid, okay, and that's melting. The process is as such, so when heat is applied to a given particle, okay, particle gains kinetic energy and they vibrate. Okay, so you can see that this is our solid particles, right? So for example, this guy here, it vibrates. Okay, it starts to vibrate a little. Okay, and when particles have enough kinetic energy, Ke means kinetic energy, at MP, which is melting point, okay, they can overcome these strong forces of attraction binding them. Remember in our previous video, we mentioned that there's some forces of attraction between them that holds them in place. Okay. However, we can change this by giving them so much energy that they keep moving about more vigorously. Okay, eventually they can overcome these rate intermolecular forces, and now they can slightly alter their positions. Okay, they can break free of the strong forces, and now they have irregular structure compared to this regular structure shown here. Okay, and when they overcome this strong attraction, okay, they break free from their fixed position. Okay, and you can see now they can move about randomly, but they are still close together. And this is the description for liquid. Okay, so we can see that the solid has successfully been changed into liquid. This is a graph showing how the change occurs. So for example, at 25 degrees Celsius is where I start to heat up my solid. Okay, as I heat up my solid, it increases in temperature, right? Okay, this makes sense. Okay, and this one don't really make sense because it's a straight line. But this is a solid plus liquid mixture. What do I mean? Because at this stage, okay, temperature remains constant. Why? Because all the heat energy supplied is used to overcome the forces of attraction between the particles. Okay, so during this period of melting, it's a mixture of solid and liquid. Okay, so some of them will be solid. Okay, some will be solid particles, some will be liquid particles. And when all the particles break free, okay, like here as such, okay, from their fixed position, they will turn into liquid and temperature will rise again. Okay, sorry about this. This is an N. Okay, so let me recap. When I heat up my solid, okay, they are all solid. They are just rising in temperature. But at this state, okay, there's a mixture of solid and liquid because the temperature does not rise because all the energy being supplied in terms of heat is being used to overcome the forces of attraction. Only when all the forces of attraction are broken down, okay, are overcome, and when they're all liquid particles now, the temperature can rise again. Okay, and that's why there's a rise here and a rise here, but this is a constant temperature at 50 degrees Celsius, for example. The x-axis is a time. Okay, this is based on time. When you heat the solid based on time. Okay, let's move on to boiling. So boiling is really from liquid to gas, and it's the same format as above. Okay, so when we heat our liquid to a certain temperature called a boiling point, it changes to gas. Okay, the process is when the heat supplied to the particle gives it kinetic energy, and particles move about faster. When particles have enough kinetic energy at boiling point, they can overcome strong intermolecular forces. IMF is intermolecular forces, keeping them close, and now they are able to move at high speeds and far apart. So these are liquid particles. Let's give them some illustration. So this particle, for example, it gains a lot of energy now via heat, to become kinetic energy. So now it's able to move very, very fast. Same applies for this guy and apply for everybody else. Okay, they're able to move so quickly that they now can overcome the strong intermolecular forces using red color here between them. So now they can totally break apart and just fly around wherever they want to. Okay, so you can see that they have essentially broken free from being close to one another. Okay, and this is what we call a gas particles, correct? This is liquid. Okay, so now they are able to move at high speeds and far apart. And this is a description for gas phase. Similarly, we have this graph here. So for example, a liquid at 50 degrees Celsius, if I continue to heat it up, okay, it reaches 75 degrees, for example. Okay, this is when it's a mixture of liquid and gas particles. Okay, because at the 75 degrees Celsius, all the heat energy supplied is used to overcome the forces of attraction between the particles. And during this period of boiling, it's a mixture of liquid and gas. Only when all the particles break free from one another, okay, when they can fly and move at high speeds, okay, and far apart, the temperature will then rise again. Okay, that's why there's a rise and rise here, but this is a constant temperature. So let's put it together. If I have both melting followed by boiling. So for example, I have solid here, okay, as it continues to melt, it will reach the melting point at, for example, maybe this is 25, this is 50. For example, it melts at 50 degrees Celsius. This will be solid plus liquid, correct? Constant temperature. And when all the solid particles become liquid particles, this will just be liquid. And so it will rise again until, for example, 75 degrees Celsius. And this is when it's a mixture again, liquid plus gas. Am I right? Then this is constant temperature again, until all the liquid particles become gas particles, and then the gas particle will increase temperature again. Okay, until wherever it stops heating. So you can see that between the mixture, there's solid, liquid, and gas. Okay, and between them, it's mixture of solid and liquid and gas. Okay, next we'll move on to freezing. Okay, freezing is really from liquid to solid. And this is when liquid loses heat to form solid at melting point. Okay, so this is a bit weird because melting point means from solid to liquid, right? Am I right? But the opposite is true. Okay, so melting point is also the freezing point of a substance. Okay, and the process is as such: as the liquid cools, the particle will lose its energy. And now it's unable to overcome the forces of attraction. Remember, at first it's moving very, very quickly. Okay, there's a lot of energy being supplied to it. But now when it cools, all this energy are being removed. Okay, so you can see that it's being removed. And now what takes precedent? Okay, it's all these strong molecular forces coming back together that holds them together. Okay, and now these strong molecular forces will pull the particles close together and hold them in fixed position. So because these particles cannot move as much now, they are being confined back to the solid state. Okay, let me draw finish right here. Okay, and now the particles are in fixed position again. Okay, and particles can only vibrate in their fixed position. So very, very minute movement. They cannot move very largely like just now. Okay, so now successfully you have converted all the liquid particles to solid particles. And this is the graph as with the previous two processes. So this is a liquid. As the temperature starts to drop, for example, this is 100 degrees Celsius. Maybe it drops to, for example, say 50 degrees Celsius. Okay, you can see that as it drops, okay, temperature drops, there exists this plateau, this straight line here, because all the energy is being used to force the particles to come together. Okay, only when all the liquid particles become solid particles can the temperature drop again. Okay, and this is the opposite for melting and boiling. Okay, now let's move on to two more processes. Next one is condensation, which is gas to liquid. Okay, so these are my gas particles. Okay, and when gas particles lose heat energy, they form liquid. Okay, the process is as such: when gas particles they lose kinetic energy, they are unable to overcome the forces of attraction between them now. And the strong forces of attraction, they pull the particle close together, and the particles move at slower speed. Okay, so for example, just now they are able to move super wildly, right? They can move at high speeds and far apart. But now, because of them losing the heat, okay, they slow down. Look at the movement. Okay, they are being slowed down. And now what comes back into place are the strong molecular forces, which will now hold them together. They will like pull them closer together. Okay, and they have no choice but to abide, right? Because there's no energy for them to move away. And now what they will form now is liquid particles, which do not have fixed shape, but actually are still close together. Okay, And that's why it says that the particles now move at slower speeds. So now from gas, I have converted them to liquid particles. Finally, we'll learn about sublimation, which is really just solid to gas. This one is the one that we skip melting point, which means that we skip the liquid phase. Okay, only certain molecules or substance are able to do this. For example, carbon dioxide. Let's take a look at how it's being done. So basically, solid changes to gas directly without melting. Okay, it skips liquid phase. So for example, this is my solid here. It just jumps directly all the way to the gaseous phase. How it's done basically is when I supply it with a lot of energy. Okay, it's so much energy that it just breaks apart from one another. Okay, such that the intermolecular forces do not matter anymore. It's negligible. Okay, just now it's very strongly held together, right? Am I right? But now it's just very weak. Okay, and like I said, only certain molecules are able to do this. Most molecules will have to go through the three phases. Okay, solid, liquid, then to gas. Okay, but for example, in the case of carbon dioxide, it's able to convert from solid to gas directly. Okay, at negative 78 degrees Celsius. And that's why room temperature, carbon dioxide is a gas, because room temperature is higher than its sublimation point, which is negative 78 degrees Celsius. Okay, and that is all for the interconversion of states, which is the change in state for metals.